Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students at Illinois State University, please go to smarturl.it/help-ISU-actuary. And here's the exercise for today for exam IFM, Investments and Financial Markets. A company is considering a franchise expansion project. It plans to estimate the project's net present value to decide whether or not it should expand. Below are three cases for the 6 different variables that affect the project's net present value. And the 3 cases are worst case, base case, and best case. The variables are initial investment, pre-tax cash flow at end of year 1, cash flow growth after rate after year 1, and tax rate, cost of capital, and project lifetime. And you have all the values for a total of 6 times 3, so 18 values. You are also given that the project has a finite time horizon and no shutdown costs. When the project expires, all cash flows cease. All 6 variables are mutually independent. The probability that the worst case occurs is 25%, the probability that the base case occurs is 50%, and the probability that the best case occurs is 25%. Also assume these probabilities are the same across all 6 input variables. Use the following 6 uniform random numbers u between 0 and 1 to simulate a value for each of the 6 variables in order from the first row of the table down to the 6th row. And here you have 6 random numbers between 0 and 1. And if u is between 0 and 0.25, less than 0.25, that means the probability of getting such a u is 0.25, and we assign the values from the first column, so the scenario of the first column to all of those values. So we pull from the worst case column. If u is between 0.25 and 0.75, pull from the base case column. And if u is between 0.75 and 1, pull from the best case column. Based on the simulated values, calculate the net present value for the project. And here's the solution. So we have these 6 random numbers, and we use them to simulate the values of the variables. For u, we have the initial investment under worst case scenario, and the value is 5,500,000. For u equal to 0.1198, we under 0.25, so we pull from the worst case scenario. Pre-tax cash flow at the end of year 1 is 900,000. For u equal to 0.1724, that's the worst case scenario, and the growth rate in cash flow after year 1, we take it to be 2%. For u equal to 0.4757, that's the base case, tax rate is then 25%. For u equal to 0.9617, that's the best case, more than 0.75. The cost of capital is 5%. And for u equal to 0.1600, that's the worst case, the project lifetime is 8 years. And then we use these simulated values to calculate the net present value. So it's the present value of future after-tax cash flows minus initial investment. Initial investment is 5,500,000. The cash flows after tax are after 25% tax. and they start out at 900,000. They grow 2%. We discount at 5% the cost of capital. Then we take this 1 over 1.05 plus 102 over 1.05 squared and so on as a partial sum of a geometric series with a ratio of 1.02 over 1.05. So every next term is increased by being multiplied by 1.02 over 1.05. And we also pulled out 1 over 1.05 factor so that this partial sum of a geometric series starts with 1, and then we use the formula of the form that it's 1 plus r squared up to r to the n is equal to 1 minus r to the n plus 1 over 1 minus r. And that's exactly what you see here. That's, of course, a generalization of the famed Chechnya formula, and if you don't know what the Chechnya formula is, you should watch my videos. So the Chechnya formula is something that got me a free trip to Chechnya. That's why I call it that. But anyway, we do the calculation of all of that, and it comes out to be negative 843,067. And that's answer B. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.